Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will apply reflections and dilations to functions. So the rules for reflections and dilations are here. Let's try this example where we have the graph of y equals f of x, and we're going to use this to sketch the graph of y equals -2 times f of x. So to do that, we need to figure out which transformations have occurred. So firstly, it's been multiplied by 2. So that's like this one here. This is a vertical dilation. So k, the number in front, is more than 1, which means this is a stretch. This is going to stretch this vertically. Sort of like, think of if you zoom out on like a map or something like that. It's going to make this look bigger. Twice as big, in fact. Now, it also has a negative out the front of the function, so that's like this one. It's reflected in the x-axis. So it doesn't matter the order in which we do this. What I'm going to do is I'm going to reflect this in the x-axis first and then perform a vertical dilation. So when we reflect in the x-axis, all of these points on the x-axis will stay as they are. But points like this will go on the opposite side. So this point here at -1 will move up here. Similarly, this point here at 1, 2 will move down here. And so after performing the reflection, the graph will look like this. So now we need to perform a vertical dilation of 2 units because this number is 2. So that means every point on this, we move it so it's twice as far from the x-axis. So these points that are on the x-axis, once again, they will stay. But for example, this point here, which is 1 unit from the x-axis, it will move to 2 units from the x-axis. Similarly, this point here, which is 2 units below the x-axis, it will double, move to 4 units below the x-axis. And now we simply join up these points. And here in the green is the graph of y equals -2 f of x. All right, let's look at this equation here. Now we want to graph f of -x on 2. So in this case, we have reflected at about the y-axis because of this negative. Note x on 2 is the same as a half times x. So we have a horizontal dilation where k is a half. Now, this rule here that it's a squeeze for horizontal dilations is true when k is greater than 1. But because here k is a half, this is actually going to be a horizontal stretch. So again, we'll perform the reflection first. This time it's a reflection about the y-axis. So this time the y-intercept will not move, but all of these x-intercepts will. So this intercept will go from -3 to 3. This intercept from 2 to -2. This point here, which is -2, 1, will move across here to 2, 1, and so on. So this is the function after it has been reflected about the y-axis. Now we're going to apply to it the dilation. So here we've established it's a horizontal dilation. It's actually going to be stretched because k is less than 1 this time. So let's think about what's happening. So for example, this intercept happens at -2, right? This is f of -2. But because I now want to divide x by 2, after the dilation, this will actually happen at -4, because -4 over 2 gives me -2. So it will move over here. Similarly, this point here will need to move over there for when x equals 4. But this point here on the y-axis, which is f of 0, that will stay where it is. And so in green, we have the graph of f of -x on 2. It's like the yellow graph, but it's been stretched horizontally. But other than that, they're the exact same graph. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.